Awesome. So yeah, 11 o'clock, we'll let people continue to file in, but welcome to another session of nTop Live. My name is Annika Norden. I'm a customer success engineer here at nTopology. We're going to share this video after it's posted. This will be also live up on YouTube, along with all the other nTop Lives that we've been doing recently. So if you missed the beginning, maybe want to look back on this later, that's all going to be there on both our website and on YouTube. But yeah, let's just jump into it. So today we're going to be looking at an assembly jig generator. I know in the past and for other nTop Lives, we have talked about jigs and fixtures before. However, those conversations, we're going to keep them going because there's a lot of power and capabilities within the jig, fixture, softgel world, especially within nTop. Within how we're working with these fields, how we're working with our geometries, we're able to bring in these funky parts and create these kinds of fixtures just with simple Boolean operations that might not be as capable within a traditional CAD software. So in the last example, you saw a kind of fixture that works as a vise. I urge you to check that out on our nTop Live. This one, on our YouTube channel. This one's gonna be a little bit different. Here we're working with some kind of like aluminum sheet metal part, some kind of electronic component and circuit board, and creating a kind of jig that can hold this up and allow for whatever manipulation assembly needs to be done on this part. So for a little more context, if we're working with electronics, we're working with maybe small, very sensitive parts that can be triggered even by like the static on your clothing. So for those who are familiar with this, working in this world, you have to wear proper equipment. You have to make sure you're in that proper environment to work on these parts. And so one way to help this is by creating this kind of jig that elevates your part off of your lab bench, elevates the part, maybe is using a specific material to help keep the static energy dispersed and away from what you're working on. So that's kind of what we're creating here. I guess we can just jump into the workflow. So we have this green part is what would be our electronic component that we're bringing into the system. We want to create some kind of jig, which is this gray part down below. If I turn off this visibility, you can see in this example, super simple, right? We just have this plate on the bottom. We have these 4 columns holding it up at those edges. Also, we have a little bit of clearance space so that we're allowing this circuit board maybe to be easily put in and out of our jig here. So to get into how this is actually made, let me turn this visibility back on. I'm actually going to isolate that. So we just see this geometry here that we want to build this jig for. So what we first did is grabbed onto the corners of this part here. So if I turn on these little points here, you can start to see we have these 4 points right along the corner. And how we did that was we grabbed the bounding box of this variable here. So you can see this bounding box just follows the shape pretty easily. This is a almost square bottom here, so pretty simple when coming together. I have another example that I'll show later that shows kind of the flexibility that comes with it. So we have our bounding box, and we've basically extracted these 4 points along the base of our bounding box. And then we put to use this closest points block by bringing in a point, basically this edge point that we have here. And with the closest point block, what that does is it takes any point in space and finds the closest point within whatever body you're specifying. So for example, we have this point here. If I zoom in, you can see that a little better. So we have this point here. We specified the body, which is this green body that we have. And by using this closest point block, you see it shoots it right in, and now we've got that point right on the edge here. So basically it did that for all 4 points along the edge to grab onto those specific points. So now let's see if we turn off these visibilities, also this guy here, and we can see those 4 points. So these are our important points on the edges of this geometry where we want to hold it up. So up next, if I scooch on down, you'll see we simply just created 4 columns. So each of these columns, we have that point as our center point, extend them down, but we want to clean this up, make it a little nicer, eliminate some material. So what we did here was an offset body. And if I open this up, we're just introducing a ramp block here to offset the body inwards so that we have this nice tapering going on here. Next up, we actually made this into a little bit more of a part here, right? By adding this plate along the bottom, joining it with our 4 columns here, and then smoothing that. So we have a nice no sharp edges. Maybe this makes it a little bit easier for manufacturing from there. And then up next is where things get a little bit more involved to actually get to where we want to be. So first up, we translated that object, moved it up so it's actually overlapping with our assembly here. And next, what we want to do is actually subtract this body from our assembly so that we can enclose it properly or hold it properly. But you'll notice if we were to just do a Boolean subtract, we'd still have these floating edges here. And that's not helpful because we want to make sure this is sitting there. We don't want some floating geometry up above. So what we're putting to use here is actually the manufacturing support volume. So what we did is we translated the fixture up higher. So let's see, this is where it originally was, brought it up in space, defined a build plane, which is where we want our assembly to actually sit. And then we use this manufacturing support volume. And basically what this is this is a super powerful block. In some cases, well, so as you see, it's called the manufacturing support volume. So meaning that this block can be used to define where you need your support if you were doing additive manufacturing, 3D printing this. But in this case, this is actually a very powerful block for other purposes. In this case, we're just grabbing onto all of this material at the bottom because we have this flat plane here. It can extend all the way down. And it's basically bringing that down to where that surface is and where we want it to be so that we can cut out that entire space and we don't have to worry about those floating bits that we saw before. So turn this into an implicit body to then act as a Boolean subtract on this final part. So if I turn off these visibilities, you'll see that where it was overlapping, we're actually cutting out from that space. And the nice part about this is because we turned it into an implicit body, we can offset that. So maybe you want to make sure that you can get that part really in and out of that jig very easily. So you can add a little offset, add a little bit of clearance to that area there. And then this is basically that final part that we're working with. If I turn this assembly back on, you can see how it nicely sits in there. Down here, we have some calculations. So we're looking at the thickness of that lower plate, the volume of this body that we're creating, maybe the surface area. We also have the bounding box of the X, Y, and Z. And by having that, that's a good way of just getting a nice estimate of how big is this geometry actually. Like, is this going to fit into my workbench properly and things like that. If I scroll up, you'll see we have a couple of things here that we can change. So looking at the corner stand width, length, and height. Maybe this is too tall. Maybe we can bump it down to 30. So this is going to regenerate. It might take a second, but also looking at the depth. Right now, we're only going 5 millimeters into that, but we can easily change that around. So now you see here, quickly regenerated. So we have this shorter structure here. Maybe when we want a little bit bigger of a clearance, so we can go in there and update that as well. However, as I mentioned before, this is a very simple geometry that we have here, right? We were easily able to grab onto those corner points. But what I can do is remove this from the variable here. So this is the original assembly, and I can bring in a different assembly. So I can plop this guy right in here. And if you'll see this was, we had our original assembly. And if I turn, and now you can see this new, sorry, original part, and now we can see the new part. So a little bit more complex, also in a totally different location. That'll just take a second to run through. As we let that run, we can start to think about how we're actually manufacturing this jig. And so you'll saw it's a pretty simple geometry, but maybe some of the next steps I could take would be to actually shell that part out, maybe chop off the bottom. So then we can do use a vacuum form to actually create this part. And so we'll see it's still generating a little bit. There's quite a bit going on because we're running through this whole entire workflow. But just within a minute or two, we're able to create this whole entire new geometry working with a whole different part, which I think is much quicker than maybe some applications some of you might be used to. And now we can see this one looks a little bit different, right? So we brought in a different kind of geometry. If we look at it from the top here, we still are grabbing onto each of those corners, but instead we don't have that even square plate, but we're still able to grab onto these parts here. Yeah, this is just being able to bring in another assembly. It reads it in the same way, does the closest points, creates those boxes to then create this part here. And if I turn off this visibility, you can see how even within these different edges, you're still grabbing onto it properly to then create this jig to help with that process when you're working with these kinds of electronics and circuit boards. Yeah, so that's about it for this. Let me look to see if we have any questions or anything coming in. So someone was talking about preparing a subtract block within a CAD program if it's available. So yes, if it's available and if you're able to do that Boolean subtract, sure, you can do that within nTop, but I think, or sorry, within whatever CAD software you're working in before. But what I think makes things a little bit simpler within nTop is when you have something a little bit more complex like this geometry here. So to start, we have to create these beams and then do that subtract operation. But within nTop, we're able to easily just read in that bounding box, locate those points, create those beams from there. And the fact that it's very automated, I think makes it a bit simpler in nTop. And then with a simple Boolean subtract at the very end, you're able to just remove whatever features, no matter how the different edges and boundaries are lining up. So definitely worth a shot trying it in another CAD software, but I think just in this example, especially with this kind of workflow and that automation, being able to bring in whatever kind of part you want and create from there, I think makes it a little bit simpler within nTop. Let's see, a couple other questions are coming in. Yes, awesome, agreed. Great to hear, yeah. So if anyone has any other questions, feel free to throw them in the chat or, oh, let's see, there is. Oh, thank you for the tip on my battery. I think we're gonna be finishing up soon, so I can indeed plug in my computer. But yeah, I think that's about it for this workflow here. Hopefully you find that useful. Also, if this specific application isn't exactly what you're looking for, I think that this is a good example of use of some other blocks. So maybe you haven't worked with the closest point block before. Maybe you haven't seen the potential within this manufacturing support volume block beyond just a manufacturing support. So by being able to see how we're using these different blocks and different workflows, hopefully you're able to pick little pieces out of that to apply them to your own workflow in the future. But yep, thanks for tuning in today. We've got nTop Lives every Monday, Wednesday, Friday at 11. So hope to catch you on some other workflows and hopefully inspire some some work as you are all working through nTop. Awesome. Well, thanks so much.